square. Further. All right. Anything from homework stuff? Okay, all right. I know we haven't done that much. In fact, just one day, right? Since we had the last one. All right, so let's go over what we've gone over since then. Well, we went over yesterday. So slight review. I think, if I remember correctly, keep myself straight. Oh yeah, okay. So we had the section that's always so exciting. You have your green book on page 127. I'll put it up on the board. Number 2. The green book, page 127. Alright, so rectangle is 5 feet longer than it is wide, has an area of 126 square feet. What are the dimensions of that dude? Okay, alright, let's not jump the gun too far. What are the players? Length and width. It sounds like Jeff wants to use W. Why is the width? Is the width the one that has a single letter?
Yeah.
Yes, why?
Because it needs that. It needs to get into that.
I need to know the width first so I can add 5 to get the length. I like it. So you always, hopefully at this point you can identify what's just going to be W or X. In this case, I agree with you can call it W. Then the length is going to be W plus 5. I draw myself a little tiny picture. So this is going to have a different way to solve it, but that doesn't change the beginning. The beginning of almost every word problem is draw a picture if it makes sense. If I'm buying a shirt, I'm not going to draw a little shirt. But if it's a geometric problem, yeah, I'm going to draw a little picture, keep myself kind of straight. What are the players? Give one of them a variable name and then build the other ones off of that. And now, of course, they're asking me about the area. They're telling me something about the area. So I know the area is 126 square feet from what they tell me, but what's the area from my picture? What's the area? Yeah. What's the area of a rectangle? The width times the length. Are you guys familiar with me? So W, the width times the length is the area. I like it. And then how do I solve that weirdness?
Move the 126 over by subtracting it and leaving it to 0.
Sure, I want to get it equal to 0, but why exactly do I want to get it equal to 0? Because what do I want to do on this side? Sorority factor. Distribute. And you get a W squared, and that tells you get it equal to 0. I like it. Let me stop for a second. Everything we've done so far in this problem, including what we're about to do, it's all old news, all of it. Right? And I know, poor little word problems. Yeah, shat on all the time. Bless you. Right? But it's word problems is how we model real life. It's a very baby step into how we model things in real life. So I modeled a rectangle. Here's the algebraic expressions for the sides of the rectangle. And then I can do stuff with it. Okay, I like it. And so what's the next step on that? Now I've got just an equation. It almost doesn't matter where it came from. How do I solve that equation? Factor 11. So I need two numbers that do what?
Multiply by negative 26.
Multiply negative 126.
9 and 14.
And they have to add the 5, 9 and 14. How could you have done that? Otherwise, well, they have to be different signs, so they have to be 5 apart. Let me stop right there. Does anybody see what I mean when I say that? I've said that a lot. I'm always curious if there's somebody out there like, said that same weird shit again. I have no idea what that means. If they're opposite signs, that means when I combine them, they're actually going to subtract. And they have to make 5, so they have to be two numbers that are 5 apart. So I could say, okay, what about 8 and 13? They're 5 apart. All right, but 8 times 13 is 104, that's not enough. So 9 and 14,
That makes sense.
that makes 126. So 9 and 14, which one is what? Positive 14. Negative 9. So how do I write this? W minus 9. So either W is 9 or W is negative 14. Mathematically, they're both valid. But in this problem, I can't construct something with a negative side length. So the width is what? 9 feet. And then the width and then the length, has to be 14 feet. Now real quick, see how that was negative 14? And negative 14 plus 5 is negative 9. Of course negative 14 times negative 9 is 126. Right? So that would still work numerically, but it doesn't work physically.
So basically, after we distribute, we're always going to end up getting both of our answers. Just one's going to get thrown away. And
No, don't say that.
No.
You might get two valid answers. That's not impossible. There might be two ways to organize something so that it works physically. Here we only got one way. But be really careful. Only throw out any answer that doesn't make sense physically. You don't throw out the negative one always, right? Even. Maybe these could both come out positive, and there's two ways to do this. There are word problems like that. But and why would I always throw out the negatives? Because it could be what's the profit, and profit can be negative. But here, this is a physical side length. That's why I throw that out. You guys with me? So don't take away the lesson. Negatives get thrown out, right? Or I always lose something. No. Maybe. How you guys feeling? Huh?
Do we just do grouping when the first?
Yes. Would it not work here? Bless you. It would still work, but it's like extra work. I already know what numbers go here. I only group, like you said, when the first number's on a 1, because I don't actually know what the numbers end up being that go there.
Okay.
Because they're not the same as the numbers I break it up with, right? Okay, maybe. Okay, let's try another one. We did one like number 3 yesterday. Ooh!
Oh, God.
You don't like it when I make that sound. Just, they've already done some of the work on number 4. Look at number 4 on page 128. I'm going to put this on the overhead because I don't feel like drawing this. Oh, that's good job.
Turn the screen on.
All right, let's see. I got Ben in there. Alright. This one is kind of nifty. Believe it or not, this kind of thing actually does happen in real life. Not exactly this specific. The rectangular piece of tin is twice as long as it is wide. So you can see they have X and 2X. Just pretend like it actually looks like that. They chopped squares. Right, so I had it originally just a big rectangle of tin, just sitting there. I'm like, oh wow, what can I do with this? So I cut the corners out so I can fold the sides up. You guys see that progression? No? So if I cut these corners out and I fold this up and I fold this up and I fold that up and I fold that up, you guys see that? Okay, I like it. So this is kind of related to a problem dealing with gutters along a house and what dimensions have the maximum volume, that kind of, this is leading in that direction. So that's what I mean. Problems like this show up in real life all the time. Let's see. Blah, 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 blah. To make a box whose volume is 480 cubic centimeters. What are the dimensions of the piece of tin? Sorry. Funkadelic is all shit. Now, first off, let me ask you a side question. If I had a container that was X, Y, and Z for the sides, what would the volume be? Anybody know? What's the area of the base? To show off my limited artistic skills. What's the area of the base? X times Y, right? You see that? The base is X times Y area? Stay with me now. Now, children, there used to be these things called records. And they came in these sleeves that were rectangular or maybe square, right? And so, just imagine, I love this formula because let's say every one of them has an area X, Y, and then if I pile up Z of them, what total volume does that go through? X, Y times Z. Because I have Z, X, Y's. So that's X, Y times Z. So what's the volume of some kind of a rectangular solid is length times width times height. That's interesting. Okay. So, what do I need to know about this shape then to figure out what the volume is? I know it's 480, but what is it in terms of the math behind this? I have to know these dimensions, right? So how long is this? How long was the entire thing?
2x.
2x. How much did I chop off?
4.
There you go. 2 there and 2 there. So what is it now?
2x minus 4.
Yeah. So this is 2x minus 4. What about this side? X minus 4, I love it. And of course they put the height on there for me because how tall is it going to be? Is that 2 centimeters I chopped off? So a slightly more interesting problem that we will not do in this class would be, what will this number be to make the volume as big as it could be? That we cannot do. And some of you guys are like, that is fine. I ain't got no tin laying around. I'm not going to try to do this shit. All right. Okay, now. Can you write the volume of this box? An expression for that. Don't tell me. Try to write it. What's the volume of that box? Don't say it. Right. You know everything you need to know. Like some of you guys like, no, I don't, Jeff. All you got to remember is the thing everybody agreed with me about was this volume is X, Y, Z. So what's this guy's volume? Say again? 4x minus 4? Times X minus 4? Times 2. But, alright, so that's an expression for the volume of any box I make out of that tin. But now I know I want that volume to equal what? What do I want the volume to be? What's it say? 480. So I want 2x minus 4 times x minus 4 times 2 to equal 480. Now before you start just going to town, multiplying shit out, do you notice how, can't I divide this 2 away? Make that number smaller? Some of you guys might even realize you can take the 2 out of this. divide it too. Make that number even smaller, because that number is gross. If I can make the number smaller, I am. Yes,
Where did 2 come from?
this too?
Yes.
So remember, the volume of a box would be length times width times height. And the height of the box was the 2, because that's how much I chopped off each corner.
Oh, yeah.
Yeah.
When it folds up, it's 2 centimeters.
Yep. So they put that down there for us because they're nice. Too bad the green book is not your teacher. I won't be that nice. So now just solve this. So here's my 2 suggestions. Even if you don't notice this, it'll still work. But I can divide by 2. I can take a 2 out of this. And divide by that 2. So now I've just got this to worry about. And that looks a lot like one we did earlier, yes.
We don't divide x minus 4 by 2?
So this is
Or is it just us?
so we had a little discussion about this last time. What's 10 divided by 2? 5. So if I have anything that is 10 and I divide it by 2, the answer better be 5. If I divide 2 by 2 and 5 by 2, I don't get 5. 2's die. There's only one 2. So the minute I divide by 2 and it dies, it's gone. It's not there to affect anybody else anymore. Alright, I like it. I know that's a little bit wonky, but let them die. They're not there anymore to do anything to us. What about the zombie? I killed him. He's dead. No, okay. So that's now exactly like this was, right? Okay, keep going. Catch up to you guys. You guys get there?
Yes.
So now the way I would do this is, again, I need 2 numbers that are 6 apart that multiply to 112. So let's see, like 8 and 14, is that the answer? Yeah. Sorry, I didn't mean to do. 8 and 14 are 6 apart, and 8 times 14 is 112.
Negative.
And which one's got to be negative?
14.
Bigger one, so that it comes out negative in the end. Right? So I get x plus 8, x minus 14 equals 0. So x is negative 8 or 14. What do we do there? Yeah, because it's trying to be a side length, I can't let that be negative 8. So x is 14, and 2x, remember, so it's x by 2x, centimeters. So 2x is 28 centimeters. So the tin was originally 14 by 28. Okay. Maybe.
Originally without the corners cut out?
Yeah, because remember, here's the picture. So what was it originally? X by 2x, and then I chopped these pieces off. So if I figure out what x is, it is what this side was originally, because that's what x means. So I call this isn't really this, but this is sort of like a cookie cutter problem where I used to have a whole thing and then I cut cookies out of the corners. We'll see a real cookie cutter problem later.
When, like next week?
I don't know. I can't. All I know is I live today. That's all I can do. All right? There's too much shit going on. Okay. So we did that. We did the word problem kind of stuff. Okay. And then we got into chapter 7. And we did stuff like this. We did stuff like this. No, I don't want to do this. Here we go. Down here. Bottom page 129. Do those real quick. Those 4. Anytime I do this, and you guys can help each other out if you want to. I'm not going to grade this. Just to make sure everybody's on the right track. For this kind of problem, what's the only thing I'm concerned with in number 1? The denominator. And what can't happen? The bottom can't be 0. That's where people get all kind of freaky. They start subtracting and saying, how do you solve for x? Divide by 6. Well, you're freaked out by the stupid 0. So that obviously x can't be 0, right? If x is 0, the bottom is 0. Some of you guys probably can just look at it and tell. Same thing with this one. Hopefully you've done enough of this kind of thing where you can just tell what b makes this 0. 3. So b can't be 3. Do number 3. I don't know, it might be partially right. There should be 2 answers, number 3. Right? 2 things it can't be.
Oh yeah, negative 2.
There you go. Because what do you do with the bottom? Why was this easy? Because it's got 1 piece, I can see that piece. It's got 2 pieces, I don't see them yet. What do I get when I factor it? So now I can see y can't be 2 or negative 2. Now number 4 is interesting. I'm not saying the others aren't. I don't mean any offense of the problems. Number 4, can you factor this? Why? It's a sum of square. I like it because it's positive. That's not really why there's no answer to this. Like this can handle every single value of r. Can anybody think for a second, what is the smallest that the bottom could be?
0.
No. No. Think. Think. What's the smallest square of something plus 25? What's the smallest that r squared could be?
4.
No.
1.
No.
2.
0. What's 0 squared? 0. And the minute you go away from 0, negative 1 squared is 1. 1 squared is 1. So what's the absolute smallest r squared can be? 0. So what's the smallest the bottom can be? 25. So if the smallest it can be is 25, is there any value that makes it 0?
No.
No. So there's no values that would make it undefined. It works for every value. So your answer would be no values. Or so you can either say no values of r, or you can say all real numbers work. They both mean the same thing, right?
Oh, yeah.
No values of r make it undefined, or you can say all real numbers work. They both answer the question. They both mean the same thing. You guys cool with that? So it's not just because I can't factor it. It's because it can't be 0. That's the more important point of that. Lock it. Okay. And then we got into this. So here's kind of like where we left off. Let's see something interesting. Yeah. Look at number 3. I don't know. Sorry. Can somebody tell me right now what's the number one mistake people are going to make? What's the number one mistake people will make on this? The instructions here would be simplify. So what is the number one mistake? And some of you guys are like, well, I would do this. Well, that's a mistake.
Cancel the A squared.
Cancel out the A.
Cancel the A squares. Why can't I do that?
They're connected.
Not that they're connected. Huh?
The division.
The division is not the opposite of subtraction addition. It's that straightforward. That's why. And I always have students, either part of the brain doesn't like it or their entire brain doesn't like it. They're like, it's freaking A squared, and I'm talking about, why can't I kill it? Because division doesn't cancel. That's basic. That's it. I'm not saying you're crazy if you do that, because we're very optimistic. Right? Let me kill that. There's less shit to look at. But it's that simple. It can't do it. So what do I do? I can do something.
Factor.
Factor. How do you factor the top?
A plus 6, A minus 6.
Zoom out a little bit. Whee! A plus 6, A minus 6. And what about the bottom? Anybody notice, real quick, you're going to love these problems. I'll bet you anything, one of the numbers is 6. You see what I'm saying? So these problems will have hints in them, and I will bring it up every now and again. So it's got to be 6. And of course, 6 times what is 42? 7. And 6 and 7 make 13. So what's on the bottom? And then what can I kill?
A plus 6.
Die. So any fraction that can be written like this will reduce like this. So if I make A some number, I'll get a fraction, and this will be a reduction of that. We saw that the other day. So why am I allowed to kill these then? I know somebody out there is like, why couldn't I kill this shit and he killed this shit? Why can I kill this shit? Because it's connected by what? To bring that connection idea in. Yeah, it's connected by multiplication. And division kills multiplication all day long. Or the other way around. They kill each other. It's not very sweet. They kill each other. Oh.
It's a platonic relationship.
Platonic? Is that your definition of platonic? I don't want to be your friend. Nice guy. Do number 7. Let's see if anybody realizes the major hint. You do one of them, and that should give you a major hint for the other one. We'll see. And again, you don't have to understand the shortcut I'm going to try to show you, because you could just factor both. Right?
You have to do that A, C.
Totally, because the first number is not a 1 and there's no GCF. Damn. Don't forget that though. If I could take a 5 out of one of those, hell yeah, because then I got a 1 up front. I can't. Oh shit. Uh-oh. If I do the top, and you factor negative 10 to make 3, and they're staring me in the face. Right?
5 and 2.
5 and negative 2, yeah. So the top one becomes 5y squared. I'm going to put the minus 2y plus 5y minus 2. Let me just focus on, holy crap. All right, Jesse. Just focus on the top for a minute, right? Let me just focus on the top. What comes out of these two? Y. And I'm pretty sure we've brought this up before, but if there's nothing that can come out, you're wrong. What can always come out? A 1. So this becomes,
5y minus 2.
okay, 5y minus 2.
Y plus 1.
Y plus 1. So that's the top. So what do you think let me draw this over here. So far I've got 5y minus 2. Let me see if you guys get this. I could do that whole same thing we just did to the bottom, right? 5 times negative 6 is 30. That make 13 would, believe it or not, be 15 and 2 and blah, 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 right? I could do the whole thing, right? Or, I'll bet you anything what is a factor of this? 5y minus 2, I bet you. Now watch. Now, again, if you don't like what I'm about to do, just do what we just did to the bottom also. Who gives a shit? You'll still get there. But let me use that hint. If that is a piece of this, what must be here to make 5y squared? A y. And what must be here to make a negative 6? There's a negative 2 here. What's got to be here to make a negative 6? Positive 3. And let's double check. I better get the middle term correct. Negative 2y plus 15y is 13y. Oh, holy shit. And so what can I kill? Die. So then you have y plus 1 over y plus 1. Just to really, really make sure people understand. If you don't like what I just did, you're like, what the hell just happened? Take this bottom, write it. 5 times negative 6 is negative 30. 15 and negative 2 make 13. Break up the middle term. I guess I'll put the positive one first. Couldn't stop myself. Take off 5y, y plus 3 minus 2, y plus 3, and you get y plus 3, 5y minus 2, which is what we got going it the other way, right? You guys kind of with me? I know I did it fast, but we just didn't want to like it. So you use a shortcut or not? It's up to you. Where we at? That's the long cut. But nothing wrong with it. I don't mean to say that derogatorily. That's beautiful. That's just more practice. I love it. I have no problem with that. Okay. Real quick, look at number 6. This kind of thing happens a lot. Do these cancel each other?
No,
Why not?
they're not the same.
They're not the same. There you go. They want to be the same, though. Do you see what I mean when I say that?
Yeah.
They want to be the same. I could take something out of one of them, and I'll end up with something that's the same.
You take a negative out.
Yeah, so if I take a negative 1 out of the top, the 3 becomes positive, and the 8 becomes negative. You guys see that?
Oh shit, that's cool.
I like that reaction. It's funny it came from you because I thought you were ahead of me on this problem. So here we go. Die. So you get negative 1. So it kind of makes sense. A minus 3 is the opposite of 3 minus a. So when I divide them, I get negative 1. Like what's 5 divided by negative 5? Negative 1. Yes.
So those can kill each other because the top is based upon multiplication, but the bottom is based on subtraction. So
Oh, it's just because they're not equal to each other. Is a minus 3 the same thing as 3 minus a?
no, but
No.
I mean like after you pull the negative 1 out,
Yes.
they can kill each other even,
Because now they're the same. Oh, I see.
even though the bottom is based on, okay.
Yeah. Is that yeah. Because what's out, understood out here, negative, there's a 1 out.
Oh,
Yeah, yeah.
You
So,
factor a 1 out.
yeah. I like it. Okay. It's sort of like here, you wouldn't tell me that I couldn't kill the 7, right?
No, that 7's gotta die.
Of course I can kill the 7. So here, I can kill a 3 minus a with that 3 minus a. The same way I can kill that 7 with that 7. I like it. Ooh, here we go. All right. So the natural next level to this. Do this problem for me real quick. This is page 132. Do that recall problem. Now, please, dear God, hopefully nobody's going 21 times 14. Let me work that out. What is the smart way to do this problem?
Reduce it.
Yes, reduce first. So what goes into 15 and 21? 3. What goes into 4 and 14? 2. So what do I get? 49 over 10. So, if I have an expression like this one, expression, they work the same way. So see how the last section, section 7.1 was this problem. 7.2 says, let me just put more shit in there. All right. So what do? I just factor everything and then see what dies. So factor this guy. These are all just a bunch of GCFs. You see that? 24 r minus 1. That's what this becomes. Times. And on the bottom, I get the 3 out. So what can I do? Yeah. R minus 1s? Die. Because everything's multiplication now, so the division can do its job. And of course, the R plus 2s are 2.
You don't see you.
And then the numbers work the same way they always have. What's 8 over 24 become? And what's 3 goes into 6? Okay, so what's left alive? So here's the major problem for those of you who are not the neatest, right? Who's left alive? And I know I watch way too many horror movies, so I'm always like, all right, zombie apocalypse. We don't want to leave the survivors out there. Still gonna get eaten and shit. You're gonna bring them with you. So who survived on the top?
6.
No, 2.
What?
Didn't the 6 cancel down to 2 with that 3? Yes. And who's alive on the bottom? 3. So this is if you really think about this, this is a really cool problem. No matter what the hell I make R, except for a couple values I'm not allowed to use. What values am I not allowed to use? 1 and negative 2. I can use any other freaking number you can imagine, and no matter what number I make R, the answer becomes 2/3. You can make R 50.897, figure out what those numbers are, and reduce to 2/3. Canon of yes, sir.
What did you kill?
What's that? No. It's really hard to see after the fact what happened. You have to watch as it's happening. So what we did was, let me put it up here again. So we factored the top, we factored the bottom, we factored the top over this way, we factored the bottom here, right? That's where we work. R plus 2's die, R minus 1's die. 8, 24 becomes 1 over 3. 3 goes into 6 twice. So the only survivors was 2 over 3. Cool? So it's all going to be about how well you can keep track of your own stuff. Here we go. Okay. So you guys try, let's see. Let's try number 5 real quick. I like that one's got some good review stuff in there. start catching up to you guys. Of course, the part of this that you guys are so excited to see. This little dude. What's the correct way to factor this guy? Little dude, big dude. 1z plus a 3. So the other 2 z's, the other 2 3's. What's the middle sign going to be?
Opposite.
Minus? Oh, sorry. I guess I wouldn't know. You guys need to see it. And now, is everything factored as much as it can? Yes. You gotta remember, you can never factor the big dude. So what dies? I can start killing stuff. Here I go, killing again. Z plus 3. Z minus 5. Anything else die? So what's on the top? 2 times Z minus 3. What's on the bottom? 2 squared minus 3Z plus 9. Now what's the only difference between multiplying 2 fractions and dividing 2 fractions? What do I have to do first here? Flip it, and then it's the same problem, right? So all these stupid division problems are the same. This is the first step, is flip and then attack, right? So this would be 1/3 times 6/5, then I reduce, and I get my answer. Woo-hoo. So look at this first one. What's the very first step on this first one? Yeah. So it'll be s to the 8th over 5 times 15 over s cubed. The numbers become what? Yes? 1 and 3. How many s's are left alive? Where? Good. So what's on the top? S to the 5th and a 3. And what's on the bottom? 1. I like it. So I'm not even going to write that shit. Right. What do you do on number 2? What do you do if you need to make him look more? Just put him over 1, yeah. All right, do number 2. Oh, yeah. Yeah, that's I didn't plan today, so I'll do it live. How many parts of that can you factor? Just the bottom one. So the first step was to reciprocate this and make it multiplication. So then division problems are nothing really new compared to multiplication problems. It's the same problem, just one extra little first step. So your y plus 2 over 1 times y squared plus 25. How do you factor this bottom here?
Y minus 2 minus
And of course, what dies?
2.
Die. So what are you left with? On the top I got y squared plus 25. On the bottom I got...
Have you seen Big now?
What's up?
Have you seen Big now? on Netflix?
That's on my list of things to watch.
Yeah.
You'll be
I had
wrong.
to finish
Yeah.
Happy first, and I finished
You'll
Happy.
love it.
Does anybody ever watch Happy? On Netflix? It's like the best thing ever. Yes.
You wouldn't factor out the
It's about like
Do it again, sorry.
middle school.
You wouldn't factor out the second one?
Which one, sorry?
The y squared plus 25.
Oh, this guy? Yeah, why can't I not factor it? Why was I able to factor this guy? Because they're allowed to be different signs, which allows them to cancel.
Oh.
If there's a plus in the middle, I can't do it because that's not going to be allowed to happen. We can't do it at the moment, but let me give a little teaser. There's a whole class of numbers we haven't even learned yet that will let me factor that
Not real numbers,
someday.
right?
Exactly.
I hate those too.
Thanks, man. It's just my life.
I love you, I just hate this.
I hate this stuff.
My dad's an accountant.
Yes.
Right, I forgot to put a number.
Where are we at, sir?
On the number one.
This one? Alright. So one last thing for today. Where's that one again? What does your gut tell you to do on this problem here?
Walk away.
And normally I say besides walk away. Your gut's gonna make you fail this bad. Now listen to me.
Factor.
What am I doing with these fractions?
You're adding them.
Adding them. What must be true before I can add two fractions?
It must be the same.
What must be the same?
The denominator.
Yes, because the denominator is the same.
Yes.
Yeah. So then I can add them together. So what are you getting on the top?
X plus 3.
Everybody cool with that?
No.
All over what?
X squared.
This is where I get all kinds of weird shit. You know that 3/4 plus 1/4 is 4 over 4, not 4 over 8, not 4 over 16. The bottom stays the same because you're collecting. I got this many x squared minus 9s plus this many x squared minus, so I got this many x squared minus 9s at the end. Now, I'm not done, because what's the very last step in any fraction problem is see if it reduces. And like somebody suggested a minute ago, I didn't have to do this yet, but now I do. If I factor the bottom, will something happen? Yes.
You'll get rid of the x plus 3, and then
Yeah.
you're left with 1
Hold up,
over
let me
x.
catch up.
Oh.
How do you factor this?
Entonces tienes más.
So what cancels? And what's the answer?
X.
Beautiful. 1 over.
Yeah.
It's so easy just to say this dude, but where is he? He's on the
denominator.
bottom. You can't just suddenly decide to come up top. No, dude, no. So what's really nice, we just talked about section 7.3, by the way. What's really nice about 7.3 is they will start off already with like denominators. What is in our future, of course, is when we have problems like this. Oh, baby. We do. How do I do this?
Yeah,
Same way we have always done it. You'll see. I think that's it. Let's call it right there. Is that all right?
Yeah. Brain hurts. When are test corrections due?
What do test corrections do?
Before the other next test.
The day of the next test.
When's our next test?
The day that test